Hello everyone, thank you for being here. Just at first, let me introduce myself a bit. My name is Tiejun Chen, you can call me Tiejun. I'm staff 2 engineer and 1 technical leader from VMware OCTO. That's an abbreviation of the office of the CTO. So you can imagine I'm working on some innovative projects. In recent years, most are related to that IoT, Internet of Things and edge computing. Before VMware, I also worked at some company like Wind River System for Wind River Linux kernel and BSP development, and even Wind River virtualization technologies, including hypervisor and our paravirtualized guest OS, and I also joined Intel OTC, Open Source Technology Center. Our team was trying to enable some hardware features to the open source project. But actually, on my side, I'm trying to get involved in something else, like robot and machine learning and even that automotive system and RISC-V. Oftentimes, I just think if I can put all of my project and even exploration together to build something new and valuable. So back here, today I'm going to talk about that can we set up this common open automotive system. Spiral, can skip this one. So I will make this with this agenda. First of all, I need to give you some background introduction, and then we can jump to introduce open source virtualized solution with our Agile, and mention a bit some automotive edge computing. Okay. So automotive system architecture. If you are from an automotive industry, you probably know that traditional automotive EE architecture to drive multiple functionality. E here means that electric and electronic. But the core of this architecture is that ECU, electronic control unit, so which consists of that MCU and sensor and actuator to given that to enable one given functionality. But when you look at all major automotive trends today, think about this advanced vehicle and even that connected car and cell phone driven car and even autonomous vehicles. New features are largely enabled to the automotive system. But the current approach to adding this new feature is generally simple. New feature, new functionality, each time you have to add a new ECU. So that has resulted in the vehicle add many ECUs. Sometimes it's over 100 ECUs. That's a problem. Adding ECU is not economic cost, or even you have to consider installation space and weight and even connective network. And ECU increase some traffic, and ECU might be too slow and unreliable to perform that level of the processing required for automotive car, something like that. So what's the next generation of the automotive system? We have that domain-based architecture. So the vehicle, the architecture designed to have multiple domains, which domain control of group functionalities. Within each domain, there are multiple ECUs, which is where each ECU control of either individual functionality or set of functionality. So typically, your vehicle has several domains, like that chassis safety domain, or that powertrain domain, or infotainment domain, or even that ADAS domain. ADAS, that advanced driver assistance system domain. ECU to capture some sensor like camera and radar to process data and make some decision. Another domain is that dynamic domain, just collects the data and send out the car vehicle. This architecture is good, but it's not enough. Think about this. Even those ECUs, they belong to one given domain, but actually these ECUs are deployed around the vehicle everywhere. You still have to use that multiple network cable and network protocol to get them connected. And I know we have several power that domain control, right? But it's very hard to share this computer power across the vehicle, use them efficiently. So another design is that zone-based architecture. We can divide the vehicle to several zones. One example is that Tesla 3 has 3 zones, central zone and left zone and right zone. Typically, we enable that infotainment functionality, and it does that functionality to the central zone. There's some problem because OEM has been slow to adapt this evolution, largely due to that safety and security concern. Because now we are running at multiple ECU workload on the single platform. Right? You have to consider security, especially the mixed criticality. Just like one specification, like that ACL, if ISO 262, it requires that freedom from interference. If two systems can interact with each other, they must be certified the highest ACL level. So how can we tackle this challenge and even meet some new requirement like that edge computing? Because automotive just like that IoT device on the wheel, right? How can we handle this huge amount of the data? We have the virtualization technology. Hardware-assisted virtualization technology can provide strong isolation between that safety critical, non-safety critical domain, safety critical domain. Even can run that legacy code to speed up that time to market. Even just leverage that workload consolidation to decouple the hardware from software to enable that operation to that workload instead of a dedicated resource or build some software-defined that vehicle. So I propose to set up this common open automotive platform with some open source project. Maybe now we can add that open source hardware platform based on the RISC-V. What RISC have? Here, I don't want to dig into RISC-V itself. I believe you already get that insight RISC-V through other sessions during this summit. But when we put that RISC-V into the context of the automotive, you have to consider something. They are also very important. The specification, even that hardware, even that chip, is supposed to be certified with some specific specification, like ACL, as I mentioned. But good news, someone is working on that, just like this. We have that sort of ACLD, that highest level complies that RISC chip. And in general scope of the functional safety, when you work around that expo, will provide that risk. A lot of that RISC-V-based vendors, they are working on this area, but from different angles, from that software verification and even debugger tool and something else. Another thing is, again, that vehicle has many data we need to handle. We need to enable machine learning to the vehicle. The good news, you can find some that RISC-V chip featured via the AI engine in a different way. To that software stack, I'm talking about virtual technology. That specification, RISC-V hypervisor, that specification is close to float. And RISC-V also supports the links. Typically, we can support that one popular that links distribution, Yocto, and we can support the Docker and Kubernetes, or even support Go. I think it's ready for that building some exploration in this common open platform. Okay, so the big story is virtualization technology in automotive system. It's not something new. Also, it's not something I personally am trying to promote. Actually, you can find some commercial that hypervisor that solution in the market, like from that global leader like QNX. But with our discussion with some of that automotive vendors, they are also looking for that open source virtualization solution. But it's not ready for some reason. We have been lacking of that some knowledge, experiment, guidance, documents. But fortunately, open source community has realized this. There are some efforts on this, like this Agile, automotive grade links. It's that a collaborative open source project. It's trying to bring them together, all together, automaker and even supply, to accelerate this development adoption of that software specific to that automotive system. Agile just like that links ecosystem specific to the automotive area. In this project, there are several groups. They are working on different targets. One group is here, that virtualization expert group. We are trying to set up this creation of the virtualized solution. We have some POC, but it's based on that Yocto. Yocto. RISC-V can support the Yocto. But we just port that QVM to that ARM base. Anyway, our goal is to provide that reference virtualization platform for the automotive system. Here on this slide, on the right side, there are two similar pictures. They are about our architecture. Our architecture is composed by several modules that enable the execution of the concrete application with different levels on criticality, on safety and security, right on the automotive system level. There are some components right here, like that execution environment. Several execution environments supported certified and non-certified and trusted and non-trusted, and communication buses. Because this consolidated workload station are needed to communicate, need to interact with each other. So two types that communication bus are supported by our architecture. One that critical communication bus is restricted to that critical EE only. Non-critical communication bus is open to all that EE available in the automotive system. Virtualization platform on this module just leverages the system on software and hardware functionality to create silos to perform that on different EEs. For our limited time, I cannot go into that our architecture in detail. So I strongly recommend you can read our white paper through that link to get inside of our virtualization platform. Or even you can find this paper through that Google research with some keywords, EGL, and white paper and virtualization. Now I talk about software. Now for the hardware, we have started thinking on how to enable that RISC-V to build such environment hardware platform. It's supposed to the heterogeneous because the automotive system is complex. You have to consider different requirements, but typically have two partitions as we thought. One is a safety critical, because you need to run some safety critical operating system with some safety critical that CPU core. And in the general partition, we can just run that general RISC-V, and even plus some hardware accelerate. Yeah, you can use that those that are RISC-V core with that AI engine, but we are common open platform, so it's open all that hardware accelerate. Actually, you can find many that hardware accelerate specific to that edge side, like that Google TPU. I'm not talking about cloud TPU. Google has that edge TPU. Intel has that VPU, or even some FPGA. So with this open source hardware platform enabled virtualization technology, we can support multiple traditional operating systems. But we want to enable some other sort of OS box to support, to carry out some application. Because now many applications are wrapped with a container. But generally, container is not very secure compared to that VM, but it's very lightweight. So instead, we just trim down that to make sure we can build such a container as a VM. Another box is a unikernel. It's lightweight OS. It's specialized single direction machine image constructed by label OS. In this OS, we just keep those necessary components to make sure we can run this application or provide this service. Just run one process. It's very suitable for that AutoSAR, that another standard to the automotive system. Another thing is a virtual lock step. CPU has that feature that CPU lock step, but we want to build some mechanism to that virtual. Now we run the virtual instance under the virtual environment. You want to keep something in the mind. When we put this system to the automotive, everything, software, hardware should be certified. But in some cases, like we want to run that machine learning, how can we get that machine learning model certified? It's very hard, right? So instead, we use this mechanism to capture the event, input and event and output to make sure what's happening can be follow up with the scope, restrict that scope. The interesting is when I try to do this, I find this reference from that internet. Just like we have a similar page, right? We have the same thing. They have a different partition, and they all have that health manager, just like our virtual log step, plays a similar role. Okay, now how can we enable that on edge computing? Because again, I'm talking about the common open platform, but the automotive system had to be interact with something like other vehicles, other infrastructure, even like ISU, roadside unit, and even part of cloud. How can we enable this on edge compute service across everything? So in this case, I want to introduce another open source project at Agile Foundry. So Agile Foundry is another open source project hosted by Linux Foundation. It aims to set up that common open edge computing framework. Essentially, that containerized that microservice architecture. You can see this big picture. There are 4 service layers from bottom to top: device service layer, and call service layer, and that's supporting service layer and exporting service layer, plus 2 other system levels service, security, and system management. I think this architecture is straightforward. I mentioned that automotive just like that IoT device on the wheel. So what we are doing with IoT, I think just 2 primary things: connect data and then send out the data. So the core service layer, the purple part, is data and the command. But we need an abstraction layer to help us build communication between those devices and our core service layer, so device service layer. On top of the core service layer, now we have data, so you can set up some rule engine and login and even user-defined additional services. You can do that machine learning service in this layer. Automotive is not that independent instance. We can use that export service layer to export our data, to share this data across this infrastructure exporting service layer. Okay. I have been working on that, but you can see there are a lot of things I'm trying to do. I will do that by step. I hope I can get something into the upstream. Maybe next time I can demo something. So that's everything I'm trying to talk about today. So any question?
How do you ensure that your VM profiles stay lightweight? What if those profiles require some peripheral function? And do you duplicate those drivers in each VMs, or do we have a separate VM that share those functions?
Share what?
In one of your slides, you show that you can host multiple lightweight profiles, VM profiles.
This way? Yeah. Okay.
How do we ensure that those can stay lightweight?
Lightweight. Okay. It depends on some user-defined profile. If you want to get some high security, you can put that application into the one lightweight OS. You can use the Unikernel, or even you can use some containerized that OS. I'm not sure if you have the Linux kit that from that Docker company. Yeah. But if you, sometimes some instance or some workload, they can be grouped in the one instance in one VM. But you still want to provide standardization between this instance in one VM, right? I have some way to provide a translation. So typically, one VM has that one set of that EPT table in terms of just like x86, right? We can assign multiple tables to one VM and then assign the EPT table to the different instance in one VM to isolate this instance in one VM. Okay, I guess time is running out. If you have any question, you can reach out to me through that. You have WeChat or maybe Twitter or maybe my email address. We can have further discussion on anything. So thank you for your time.